All right, so we're continuing where we left off today in class. The last thing I handed to you was your homework sheet and the notes that said geometric shapes in the plane. So we're going to be using the distance formula. We're going to be using things that we already know about parallel and perpendicular lines in order to solve these kinds of problems. And we're also going to be using what we know about two-dimensional shapes, like your squares, triangles, rhombus, trapezoids, stuff like that. Stuff we know about those things in order to solve these problems. So the first problem says, which statement best describes the triangle formed by joining the points A, -3, 6, B, -11, 2, and C, -4, -2. Alright, so the first thing you need to do is think about what do you know about triangles. So you guys had a sheet that had your two-dimensional shapes on them and that gave you characteristics of each two-dimensional shape. So some things we know about triangles should be that they can be scalene, equilateral, and isosceles. Scalene means that no sides are equal. Equilateral means that all sides are equal. Scalene means that no sides are equal. You could also have a right triangle, which means there's a right angle inside the triangle. An acute triangle, which means all angles are smaller than 90 degrees. Or an obtuse triangle, in which one angle is greater than 90 degrees. Okay, so now we know all about triangles. Let's graph the shape. So we're going to take the points A, B, and C and graph them on the coordinate plane. So A is at -3, 6. So I'm going to go to -3 and go up to 6. This is A. B is at -11, -2. So I'm going to go all the way over to -11 and go up to 2. This is B. And then C says -4, -2. So I'm going to go to -4 and then down to -2. Okay, that's C. Just like this. Okay, so now I'm just going to connect the points. Okay. All right, so we have some sort of triangle going on here. We need to figure out, is it equilateral, right, or isosceles? Now, one of these I can go ahead and eliminate because I don't see anything that looks like there is a right angle here. So I'm going to eliminate answer choice B. All right, it could be equilateral or it could be isosceles. So we need to find out the lengths of the sides in order to figure out which one it is. Okay, if all of the side lengths are the same, then it's an equilateral. If only two are the same, then it's an isosceles. All right, so how do we find the lengths of sides? We have to use the distance formula. The distance formula used in the plane is going to give you the length of BA, AC, and CB, okay? All right, so first I'm going to use the distance formula for side A, B. Okay, so A is at -3, 6. B is at -11, 2. So I'm going to plug those into the distance formula. My distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, before I plug them in, I need to label my parts. X1, Y1, X2, Y2. And now I'm just going to plug them in their correct space. Alright, so X2 is -11. So -11 minus X1, which is -3. If I have minus a -3, that should change it to +3. Okay? Because two negatives will make a positive. Here, let me show you that. All right, if I have minus a -3, now I have two negatives. So So two negatives will make a positive. So I can just change this to plus 3. Okay? Squared. And then I have y2, which is 2. Sorry, put the plus in between. y2 is 2 minus y1, so that's minus 6. And that's also squared. Alright, so now I just need to do what's underneath the square root. Okay, first I have negative 11 plus 3. That's negative 8 squared. And then I have 2 minus 6. That's negative 4 squared. Okay? Now, negative 8 squared is 64. Negative 4 squared is 16. Add those two together and I get 80. Okay, so the side AB, the distance from A to B, is the square root of 80. Alright. So if you need to pause the video and write that down, then go ahead and do so. Now, we are not done. We have to do the distance formula for B and C in order to see what kind of triangle we have. If we have equilateral or isosceles. So now I'm going to do the distance formula again because I need to find the length of BC. Alright, so I'm going to move this down some. Alright, so for BC, okay, B is at negative 11, 2. C is at negative 4, negative 2. Okay. I'll write my distance formula. Okay. And I label my parts. So this is x1, y1, this is x2, and this is y2. Then I plug them in. So x2 is negative 4 minus x1, which is a negative 11. So that's minus a negative 11, which changes it to plus 11 squared. And then plus y2, which is negative 2, minus y1, which is 2. So negative 2 minus 2. And square that. Okay, and so now I'm going to do what's underneath the square root. So negative 4 plus 11 is 7. So this is 7 squared. And then negative 2 minus 2 is a negative 4. So that's negative 4 squared. Alright, 7 squared is 49. Negative 4 squared is 16. Add those two together and you get the square root of 65. Okay, so the side BC is equal to the square root of 65. Whew. Okay, so one more. Hang in there. We got one more to go. So far we have AB being the square root of 80. We have BC being the square root of 65. So let's hope that the square root, that the length of CA will be either the square root of 80 or the square root of 65. And then that will give us an isosceles triangle. Okay, so now we're finding CA. C is at negative 4, negative 2. A is at negative 3, 6. Okay, I'll write my distance formula. Okay, I label my parts. This is x1, y1, x2, y2. Okay, and then plug them in. So now I have x2, which is negative 3. So negative 3 minus x1, which is negative 4. So that's negative 3 minus a negative 4, which changes it to negative 3 plus 4. And then I square it, add y2 minus y1. My y2 is 6. My y1 is negative 2. So that's 6 minus a negative 2, which changes it to 6 plus 2. And then I square it. Okay? All right, so do what's underneath the square root. Negative 3 plus 4 is 1. So this is 1 squared. Add 6 plus 2 is 8. So 8 squared. One squared is 1 plus 8 squared, which is 64. Add those two together, I get the square root of 65. All right, so this is the side CA and is equal to the square root of 65. So, all together, we have AB equal to the square root of 80, BC equal to the square root of 65, and CA equal to the square root of 65. So we have two sides that have the same length, here and here. So that makes it isosceles, and the two sides that are equal are BC and CA. So that makes our answer choice C. Alright guys, if you need to watch it again, I know this video was long, but if you need to watch it again, watch it again. And if you have any questions about the video, just post them to Edmodo or underneath the video on YouTube. And stay tuned for the next 3 examples. The next 3 examples are not as long. You don't have to do the distance formula for every single problem. Okay? Alright. See you tomorrow.